What's up everyone, Patrick here, welcome back. And in this next question, we are given this quadratic y equals negative 2x squared plus 4x minus 1. And we have to find the vertex, the y-intercept, the x-intercepts, and they're actually going to be exact values, not integers. And then with all that information, we're going to graph the function. So notice we're given this quadratic in standard form. Right? It's in the form y equals ax squared plus bx plus c. And so, number one, finding the vertex, we can do it multiple ways. We can complete the square, which I'm going to do. I'm going to do that the second way. The first way, if this is in standard form, the easier way is you can find the x value of the vertex quickly with the formula negative b over 2a. Right, so let's list these out. What's the a value? It's negative 2, the b value is 4, the c value is negative 1. So negative b, which would be negative 4 over 2 times the a value of negative 2, notice this would be negative 4 over negative 4, which would give us positive 1. So that would be the x value of the vertex. And then if you want the y value of the vertex, you just take that x value, plug it into the function. And when you do that, you'd end up with negative 2 plus 4, which is positive 2, minus 1 would give you 1. So the vertex is actually just 1 and 1. Now, if your teacher doesn't allow you to use this formula, over here, some want you to complete the square, like the question may say, find the vertex by completing the square. If you're to do that, what you got to do is you got to first factor out a negative 2 from these two. So that would be x squared minus 2x, and then the minus 1 we leave on the outside. And then what you do is you take that negative 2 in the bracket, divide it by 2, and then square it. So we would end up with negative 1 to the power 2, which would be positive 1. And so what would happen is we'd end up with negative 2x squared minus 2x plus 1 minus 1. So it's like we're adding 0. We're not changing. This and this are the exact same thing. We're just adding more to it. We're adding this, what we get. And the reason why is because we're going to eventually end up factoring, and it's always going to be a perfect square trinomial to get it into that vertex form. This allows us to get that perfect square trinomial, that step. But before doing that, we got to take this negative 1 out, but if we take it out of this bracket, because there's something in front, in this case, we got to take it and multiply it by that. So the next step, we leave the positive 1, we take the negative 1 out, but we'd multiply it by negative 2, so it would end up being positive 2, and then we have the minus 1 there. And then this would end up being, this here factors into x minus 1 to the power 2. Right? This value is always going to be half of this value, and then this sign is always going to be the same as that sign. Right? This here factors into x minus 1 to the power 2, and then plus 2 minus 1 is just plus 1. Like that. And so notice that we converted that standard form quadratic to a vertex form. This and this are the exact same thing. If you took this, expanded it, you would get that quadratic. And then from here, since it's in vertex form, we could tell the vertex is 1. It's always going to be the opposite sign. And then this 1. Right? As a review, if you have a quadratic in this format, the vertex is always going to be h and k, right? H and k, right? So whichever way you do it, the vertex of this is 1 and 1. What about the y-intercept? Well, the y-intercept is, it's pretty simple because it's in standard form, so we just have to plug in 0 for x, and it's just going to be that c value that's remaining. So it's going to be negative 1. So the y-intercept would be 0 and negative 1. right? If we plug in 0 for x, we'd end up with y equals -1. And then the x-intercepts as exact values, notice that, let me rewrite this again, this doesn't factor smoothly. Right? If we multiply these two, there's no two numbers that add up to +2 or multiply to +2 and add up to 4. So it's not going to factor smoothly, so we have to use the quadratic formula. And so it would be -b, so -4 plus or minus b squared minus 4 times a times c. And that's going to be all over 2 times the a value of -2, like that. And then from here, what would happen is we'd end up with 16. This would be +8 minus 8, so we'd have 16 minus 8, which is just 8. And then we'd have over here -4 in the bottom. Now √8, that actually simplifies. That simplifies to √4 times √2, which is 2 √2. √8 and 2 √2 are the exact same thing, and you want to simplify this as much as possible in case this is a multiple choice test. So the next line would end up being -4 plus or minus 2 √2 over -4, like that. And then from here, what we can do is we can factor out a 2. So that would be -2 plus or minus √2. And this would be over -4. And then 2 goes into -4 twice. So what we would end up with is -2 plus or minus √2 over -2. And then if you want to make it look nicer without these negatives, what you can do is you can actually factor out a negative from that numerator. So we could take out a negative here, and what would happen is this positive would turn into a negative, but then this negative would turn into a positive. And so you'd actually end up with the same thing over here in the middle, right? It would just be 2 plus or minus √2 again, and you took out the negative, and then it could cancel out with that bottom, right? So this is kind of a unique scenario. Basically, to generalize this, if you end up with, let's say, -m plus or minus √n, for example, if I take out a negative, this m would turn into a positive, but then this plus or minus would still stay the same. This positive is turning into a negative, and then this negative is turning into a positive, so it's still just plus or minus, and then that √n would stay the same, right? Just so you're not getting confused there. So here, took out a negative, 2 plus or minus √2 over -2, and then the negatives cancel out. And so we end up with 2 plus or minus √2 over 2. So those would be the two x-intercepts. So they would actually be x either equals 2 plus √2 over 2 or 2 minus √2 over 2, like that. And then approximately decimals, they wanted the exact value, so that's what it would be. But if you were to get the approximate decimal values, this would be approximately 1.7, this would be approximately 0.3. If we round to 1 decimal place. So there's going to be more decimals, but I'll just leave it like this. All right, so those are all the characteristics of that function right there. Now, when we graph it, the vertex would be at, let's go up by 0.5, so 0.5, 1, then we'll have 1.5 and 2. Same thing here, we'll have 0.5 and then 1, and then negative 0.5 and negative 1, like that. So what would happen is the vertex would be at 1 and 1 up here. The y-intercept would be at 0 and negative 1 down here. And then the two x-intercepts, 1.7 would be about over here. And then 0.3 would be about over here. Right, so connecting everything, we'd end up with something like that. And this does open down because that a value is negative. Right, so that's how the quadratic would look approximately. And notice how these, another thing I want to mention, notice how these x-intercepts actually make sense, because remember we could also find the vertex from the x-intercepts. What we can do, the x value of the vertex is always going to be the midpoint between the x-intercepts, and if we take both of these, 1.7 plus 0.3, and divide it by 2 to find that midpoint, we'd end up with 2 over 2, which would be 1, which would be that x value of the vertex. And we rounded these here, but if you took the full decimals of these, added them together, you'd end up with 2 in the numerator as well. So when you divide it by 2, you'd end up with 1. So that's a nice way to check whether your vertex was correct with the x-intercepts, assuming that in the question you found the vertex earlier in the process. Right, so those are all the characteristics, and then that's the graph of the quadratic.